This is number 1 on page 390. So you had the graph that they gave you, and it had an upside down parabola. Oh, I don't want that color. Starting over. You can't stop me. All right. X and Y axis. And then we had a parabola that went like this. And then you had a line up here that was something like this. That is just some lovely drawing right there. That is beautiful. So the one line was y equals 9. So that's the line that occurs where every point on that line has a y coordinate of 9. The parabola was y equals 25 minus x squared, and you're trying to find the area bounded by that curve. In order to do that, you need to find those two places where they intersect, because those are your boundaries. It's the leftmost boundary over here and the rightmost boundary over there. And the way to find that is where those two curves intersect, and where they intersect is where the two are equal to each other. So I write the parts where y equals 25 minus y squared, so that goes on one side. Y equals 9, that goes on the other side. And I'm solving, so I'm going to bring the x squared over, and then bring the y to the other side. I mean the 9 to the other side. So I move the 9 over there, I move the x squared to the other side. I get x squared equals 16. Remember, when you solve for x squared, you're going to get not only a positive answer, but also a negative answer. So you have your left and right boundaries of -4 and +4. And so now your job is just to look at the picture and determine which one is the top curve and which one is the bottom. Because you are doing, it's kind of like you're drawing an infinite amount of lines. And so you're getting the distance or height for all those lines. And the integral will add all those infinite values together, and that gives you your area. So the height is from the top curve down. So it's 25 minus x squared minus the bottom curve, which is just equal to 9. And we're going from -4 to 4. Got to scoot everybody up. All right, so you're doing your integration now, so that it gives me, oh, sorry. Okay, this is something that I noticed in class that I want you to work on, which is kind of funny because I just made that mistake. But make everything as simple as possible before you do calculus, and make everything as simple as possible before you plug in values. Simplify everything. Combine like terms. You never want 3 expressions to do the antiderivative of when you can have 2 of them. So 25 minus 9 is 16. So I really just have 16 minus x squared. And that's what I want the antiderivative of. So I get 16x minus x cubed over 3. You're plugging in your values of 4 and -4. When I plug in 4 for x, I get 64 minus 64 thirds. And when I plug in -4, I get -64 minus -4 cubed is -64 thirds. All right, so that's all the stuff that you have. Don't try to do stuff in your head. Everybody's really bad to do things in your head. Write that subtraction down. You know, because you're subtracting the value you get when you plug in 4 and -4. Write that down. This right here, that's subtraction. Write it down. Write the sign you get when you cube. You're going to make errors when you don't write stuff down and you try to keep too much in your head. So I have 64 minus 64 thirds. All right, we got all kinds of stuff going on. Rather than try to rush through it, let's clean up what we have in here. I have minus 64. Those two negatives give me plus 64 thirds. Okay, and now remember you're distributing a negative. So I have 64 minus 64 thirds. Then it becomes plus 64, but then minus 64 thirds. So you're kind of doubling everybody. I am going to have to get a common denominator here, but before I do that, I'm going to combine my two whole numbers there. So I got 128 and minus 64 thirds and another negative 64 thirds give me negative 128 thirds. Okay, and I do need to combine those two. So I've got to get a common denominator. So multiply that little fellow there by 3. 4, 2, 8. What? Yeah. 384 thirds minus 128 thirds gives you, looks like 256 thirds. And there we go.